Welcome to the last section of Chapter 2, Section 2.6, involving solving inequalities. Now, everything that we've done so far was an equality, where we had an equal sign. Now, what we're going to do is change it up a little bit, and instead of having an equal sign, we'll have greater thans, or less than, or equals, or less thans. And the fact that you used a less than in the problem makes it an inequality. And the difference between an equality and an inequality is that when you have an equality, there's only one answer. That's it. And we've been from section 1 to 1 to 1.5, we've been always getting one answer. Now what you're going to do is get a range of answers. Okay, and a range of answers means, for instance, if I ask you, what is the answer to this problem here? X is greater than 5. You're going to say, well, X could be 6, right? 6 is greater than 5. 7 is greater than 5. 8.5 is greater than 5. 9 3/4 is greater than 5. You can get the idea. There's an infinite number of answers. There's a whole range of numbers that I can plug in for X that are greater than 5. All right. Similarly, like you could say, hey, could I use 4? No, 4 is not part of the answer. 4 is not an answer to that problem. 4 is greater than 5 is not true. It's false. So you're going to see a range of answers that could possibly be chosen for X for these problems. Now, don't worry too much if there's a radically different way of solving inequalities. There isn't. It's pretty much the same as equalities except for one important difference, and I'm going to tell you what that difference is once we see it, once we hit that roadblock. Okay, so let's take a look. And these are one of these multi-question things. I hate that when they do that. They say we have 18 problems, but these are 4 problems inside of one. I don't like when they do that, but hey. That's what they did. All right, what they want you to do is ask, hey, is the value of 1, can I plug in 1 into this expression, and will that expression be true? Okay, first off, if I plug in 1, 3 times 1 is 3. You got to do your multiplications first. Okay, 9 minus 3 is 6. Is 6 greater than 6? Nope. Not true. Is 6 greater than 6? False. Final check. Okay, fantastic. All right, plug in 5. So this time, this is a little bit more complicated. I'm gonna do this out. Everywhere I see an X, I'm gonna plug in a 5. 5 in parentheses 5 minus 9 is less than or equal to 3 times 5 plus 1. Okay, so let's evaluate the left side. 25 minus, this is going to be 25. Multiplications first. 25 minus 9 is 16. Is that less than or equal to, let's see, this is 15 plus 1. And 15 plus 1 is 16. Yeah, that's true. 16 is less than or equal to. Well, it's equal. Okay, sure, that's true. That's true. Let's see what the next one is. Well, here's what you're going to do. I don't think I need the scratch sheet. What they want you to do is plug in minus 8 in for X. Yeah, let's show you. Let's do it over here. 7. Plug in minus 8 for X plus 7 is less than negative 8. You got to do the parentheses first. Negative 8 plus 7 is negative 1. That's what those parentheses indicate for a value. And negative 7 is less than negative 8. Well, negative 7 is not less than negative 8, because remember in the number line, here's 0, and let's pretend we go negative 7's over here. Let's pretend it's there. Negative 8 is over there. So anything, negative 7 is greater than negative 8 because it's to the right of that point. So any point to the right of the other is greater. And negative numbers can be a little confusing because you're used to positive numbers and seeing the way they work. But negative numbers, when you plot those out, negative 7 is right there. Negative 8 is less than. Okay? So what they're trying to say is false right here. Negative 7 is less than negative 8 is false. False. Okay, and last but not least, this will require a little bit of paper. Extra sheet of paper here, file new. And we'll do this and move this over here. Okay, 10x. Well, I'm going to plug in negative 4/5 for x. So 10 parentheses negative 4/5. Okay, plus 12 is supposed to be greater than or equal to 15 negative 4/5 plus 18. All right. Got to do the multiplications first, of course. So the best way to do that is 5 divides into 10 2 times. And 2 times minus 4 is negative 8 plus 12. And so while we're on the left-hand side, why don't we just add those two? Negative 8 plus 12 is 4. It's supposed to be greater than or equal to, well, what's this? 5 goes into 15 3 times. This is supposed to be 3 times negative 4 is negative 12 plus 18. Negative 12 plus 18 is 6. Not clearly 4 is greater than or equal to 6 is not true. Check your answer. There you go. So those 4 have been done. And now we have some number lines to deal with. And so these number lines indicate the regions that make these inequalities true or false. And so x being greater than 5, you're trying to select the region where that's true. Well, geez, I think anything to the right, these are your critical points. It seems like negative 5, positive 5 is the magic number there. But some of these are graphs that have solid lines and some that have graphs that have hollow or not filled in lines, hollow lines. And so which of these would be true? First off, I would not even consider the solid line ones because the solid line says, the solid dot. Don't even consider that because that indicates that you're including the 5. That would require that you have an equals associated with that greater than or less than. There is no greater than or equal. So what you're doing is saying, well, find numbers not including the 5. So that's why you have this hollow dot that I'm only going to consider A or B. And because x is greater than 5, anything to the right is bigger than the 5. It can't be A because you're saying, hey, 2 is within this region. 2 is greater than 5? No. Cancel that. This is the region. Pick a point there. 6 is greater than 5. 8 is greater than 5. I'm going with C. Check your answer. Fantastic. Let's do this one. Now, this one has an equals to it now. Remember? Equals. Now, equals means I want to include the point. Forget about B and D. B and D are not including that point 1. So you're trying to find the region that is of numbers that are bigger than or equal to 1. Those will have to be to the right. Numbers to the right are bigger than the value here. So I'm going to go with C. Well done. Okay, this is x is less than or equal. So if it's less than or equal, the critical point is this guy here, negative 9/2. And what you want to do is make sure with the equals, make sure you pick the graph that has a solid dot. Okay, B and D have solid dots. Now, you want to pick those values of x. In each of these graphs, you have negative 9/2 or 4.5, negative 4.5. That's true. Each of these things have negative 4.5. And the value of x less than or equal to negative 4.5 has to be numbers to the left. See, negative 6 is less than negative 4.5. I'm shooting for D right there. These are bigger. Anything to the right is bigger than that critical point. Okay, so far so good. These graphs are not that intense right now. So this guy here is saying two things. Okay, it's really a shortcut for. Here's what this means: 0 is less than or equal. Less than x, and x is less than 7. What this is basically saying is that I want x greater than 0 and this is and x is less than 7. I want that region where x is bigger than 0. See this guy here, x is 0 is less than x is the same thing as saying x is greater than 0 when you reposition those the variables. If you change the x and the 0 and put them on different sides, the arrow always points to the smaller end. So x is bigger than 0 and x is less than 7. Okay, interesting. Now I'm noticing over here I have basically two critical points, 0 and 7. Okay, and so what we want to do is find a region that has values bigger than 0. Okay, so forget this A. I'm looking for numbers bigger than 0, and certainly 4 is bigger than 0. Okay, so bag that. And it's got to also be less than 7. So I'm considering this range here bigger than 0 and to infinity, and a region where x is less than 7. So here, let me just show you here on the number line. This is 0. Let's make a better looking 0 than that. Okay, here's 0. And here's 7. I want numbers bigger than 0, and at the same time I want numbers less than 7. The only region that really fits the bill is this region right here, the numbers in between. Okay, that's the only region. And I wouldn't even consider C because there's no equals on these numbers here. So I'm going to go with the hollow lines here, right there. Check your answer. Fantastic. Now look at this. X is great is 1/2 is less than or equal to x, and x is less than 4. So x has to be bigger than 1/2, and x is less than 4. X has to be bigger than 1/2. Bigger than 1/2 would be, okay, like C. X has got to be bigger than 1/2, and I'm shooting for this guy here because I see an equals associated with that 1/2. I want to include it, so I'm including that range, and at the same time, x has to be less than 4, but not including the 4. Okay, and that would make a set of points in this direction. And so the only region that would satisfy both conditions is this guy, number C. Now we get to graph things. Let's graph some things. Now, the way you graph with inequalities is pretty much the same as the way you solve an inequality is pretty much the same as how you solve an equality. You basically do the same operation. So I'm going to but there is one big difference. When I show you the difference, I'll emphasize it then. So let's say new. Okay, let's come over here and just write down the problem. V plus 2 is less than -6. What would you do if there was an equals? You'd subtract 2 from both sides. Perfectly okay. That's the same thing. Okay, V is less than 8. Okay, v is less than -8. -8, I'm sorry. Okay, so far it doesn't look like anything different. Okay, and so now they also snuck up on us a little question here that said, which graph represents v is less than -8? Less than -8, no equals, to the left, 8. This is guy. Nice. Okay. What do you do here? Okay. X, I would add 7 to both sides. What would you do if there was an equals? You'd add 7 to both sides. Okay, so you'd have x minus 7 is greater than -4. Add 7 to both sides. Okay, 7 plus a -4. So add 7 plus a -4 is 3. X is greater than 3. The solution is x is greater than 3. X is, they even give us a little greater than sign. Greater than 3. Check your answer. And you're going to say, well, gee, they snuck a little answer here. X is greater than 3. The critical point is 3. So forget, I don't even know where they come up with these things. It's an E and F. But x is greater than 3. That's the critical point. Greater means in this direction. I don't want to include the 3 because there's no equals in the original problem. I'm going to go with D. Nice. Very, very nice. Now even, okay, I so far I haven't encountered the difference in how to handle inequalities with equalities, but let's just continue. Even this problem doesn't really show it. I'm going to add 5 to both sides. That cancels. -3 plus 5 is 2. -3 plus 5 is 2. Is greater than or equal to x. Now be careful here. This is true, but look at the way they wrote. They didn't want us to write this entire expression ourselves. They're forcing us to put the x on the left. Okay, so you could put the x on the left, the 2 on the right, but make sure the arrow points to what was supposed to be the smaller end. So x is less than or equal to 2. Like so. Check your answer. Very good work. They snuck at us. Let's see, they want us to do double the work. What we want, the critical point is 2. Okay. We want x is less than or equal to 2. I'm looking at A right from the top. Okay, because I have a solid dot including the 2 with the equal sign, and anything to the left is in fact smaller. Nice. So that's halfway done. Okay. I know what you're saying. You're hanging on this, hanging by your seat saying, what is the real difference between inequalities and equalities? What do we do? Here's the difference. Okay. And I'm going to put this right here. And I'm going to put that right there. And I'm going to pick a nice big font. A nice big font. Let's say 18 font is big enough. Okay. If you find yourself multiplying or dividing by a negative number, then switch the direction of the arrow. Okay, place it. Oh, of course, it's too big. Okay, so I guess we'll have to put a little bit more space here. Okay, put this over here. Of course, If you find yourself multiplying or dividing by a negative number, then switch the direction of the arrow. Pretend you see arrow over here. Okay? I needed a bigger sheet of paper to put that sentence there, or at least hit enter. Sorry about that. So far, when we solved the previous inequalities, we never had to multiply or divide, let alone multiply or divide by a negative number. So let's take this guy here, see if we have to apply that. Cancel that. Let's come over here and say, well, 7/10 x is less than negative 28. How would you solve this if there was an equals? Well, if you have a fraction, you multiply by the reciprocal, both sides. Now, are we multiplying or dividing by a negative number? No, we're multiplying by a positive number, so leave the direction of the arrow the way it is. This cancels. X is less than. 7 goes into 28 4 times, negative 4 times. Negative 4 times 10 is negative 40. Okay, so I'm going to leave the, where's negative 40? Where did I put that? Okay, put this over here, I suppose. Put that over here, and so what do we have here? X is less than negative 40. Excellent. Okay, so oh, of course we gotta go through this just when you think it's done. X is less than hollow line to the left, right there. See. Good job. Good job. Good job. Good job. Okay, the magic is going to happen now. Here it is. Separate. Negative 12x is greater than 36. Well, to solve that, I would have to divide both sides by negative 12. Negative 12, and bingo. Okay, I am multiplying or dividing by a negative number. I must switch the direction of the arrow. Make it point the opposite way. You still have to evaluate these expressions on both sides. This cancels, you got the x. This is 36 divided by negative 12 is negative 3. You still have to do that. So what I'm going to do is plug that in. X is less than negative 3. See, now remember, it originally was greater than, but because we're multiplying or dividing by a negative number, you switch the arrow. Notice the direction I picked, it's opposite from that. Check your answer. Great, see? That's the only real big difference in doing, oh, of course. X is less than negative 3. Hollow line on the 3. Oh, nope, on the negative 3. On the negative 3 to the left, right there. Okay. This one I don't need any paper. I'm dividing both sides by 7. Okay, so what am I dividing by? A positive number. Don't switch the arrow. So divided by 7 here, I get x. Okay, I divide that side, the left side, by 7. So I get a plain x. And it's a positive number, so don't need to switch it. 0 divided by 7 is still 0. Check your answer, and there you go. Huh? I bet you don't want to. I bet you don't want this video to end because you're having so much fun learning about inequalities. Let's see. X is greater than or equal. Solid dot. Solid dot. I'm looking at a solid dot on 0, and things to the right are bigger than 0. I'm looking for B. Nice work. Okay. I want you to do that. I'll do it. Never mind. I'll just do this. I'll do it myself. Just do it myself. Don't save it. File, new sheet of paper. Come over here. Write the problem out. Negative 5. 5/4 x is greater than or equal to -5. Well, by golly, I know how to handle that. I have to multiply both sides by -4/5. Take the reciprocal. The negative separate. The reciprocal of 5/4 is 4/5, but you still have that negative. So -4/5. Whatever you do on one side, you do on the other. Okay. This cancels. Leaves you with the x. What have I just done? I have multiplied both sides by a negative number, -4/5, which means I have to change the direction of the arrow. 5 goes into -5, -1 time. -1 times -4 is 4, and I can't see any more than that. X is less than or equal to 4. Let's pick less than or equal to. Notice it's different direction. To 4. X is less than or equal to 4. Hit enter. Nice. Nice. You think less than or equal to. Solid dot. Less than means to the left. Right there. Okay. Now we're going to do some math. Because we got x's on both sides. -5x plus 7 is less than or equal to -4x plus 1. All right. What would you do if there was equals? I would set that. You want the numbers to be on one side, so I'm going to say do the opposite. -7 minus 7. Now notice that when you do inequalities, we don't really care at all about adding or subtracting. What happens when you add or subtract? It could be a positive number, negative number. It has no bearing on the direction of the arrow. So I'm going to still just cross that out. I have -5. X is less than or equal to -4x minus 6. Okay. Now I got x's on both sides. Let's put the x. We got to put this at this term. Bring this term on the other side. We shouldn't have any x's on the right, so I'm going to add 4x here and add 4x here. And again, we don't switch the arrow because we're adding things. I don't care about that. I'll even emphasize that by putting it there. This cancels. -6. -5x plus 4x is -1x. Okay. And now I don't want -1. I don't want -1x. I want x. So I'm going to divide both sides by -1. And look at this. Look at what we're doing here. We hit the magic condition. We have found ourselves multiplying or dividing by a negative number. I switched the direction of the arrow. You still have to perform the operations, though. The double negatives cancel, leaves you with x here, and this is 6. There you go. So I'm going to go in here and type in x is greater than or equal to 6. Nice. Just a few more. We're done. Just a few more. I was going to go with a different video, but, you know, at this point, we're almost done. We're almost done. So we'll just stick with the same video. And let's see if we get to pick it. Well, let's see what we have to pick. -3. Have to solve it. Plus y plus 5. This is -3 times that bundle. Less than -15. Okay, what are we supposed to do? We do the same thing. Whenever you have parentheses in the problem, you got to get rid of the parentheses. Multiply through. -3y. -3 times 5 is -15. Okay. Let's add 15 to both sides. That cancels here. And because we're adding 15 to the right, it's also 0. And notice I don't switch the arrow because, you know, that switching of the arrow only happens when you're multiplying or dividing by a negative number. Okay, now, ooh, look at this. I am. If you want a y by itself, you have to divide by a negative number. Boom. Y is greater than 0. 0 divided by negative 3. 0. And I had to switch the arrow, so I'm going with that. Okay. Did I do something wrong? Did I do something wrong? I did. Obviously, I did do something wrong. Let me just make sure. The negative 3y, negative 3 times 5 is negative 15. I add 15 to both sides. Cancels, cancels. Less than. Oh, I picked the wrong one. I picked the wrong one. This is y is greater than 0. Maybe these videos are too. Maybe these videos are too tiring. Okay, 3 more, and it looks like we have a word problem. So I'm going to start out nice and fresh. File, new. Okay. Let's get this over here. Okay. A metal stays solid at Fahrenheit temperatures below 1620.5 degrees. Okay. Determine, in terms of an inequality, which is what we have here, those Celsius temperatures for which the metal stays solid. Okay, so here's what we want to do. But basically they're saying this. There's 2 forms of temperatures. There's Fahrenheit and centigrade. America uses Fahrenheit. The rest of the world uses centigrade. Okay, so if you're given a centigrade temperature, you're supposed to convert that centigrade temperature using this formula right here. Okay, because F is equal to this formula. You plug in C and then you calculate the F. Basically, what you want to do is make sure that this value is less than. Okay, if it's below, not equal to, below. So what I'm going to say is 9/5 C plus 32 has to be less than 1620.5. Now you might say, well, do I include 1620? They didn't say include it. They said it has to be below. Otherwise, they would say below or equal to this. So I'm going to search for this formula. I'm going for A. I'm going for A right there. Check my answer. Nice, yeah. That's it? Okay, good. Good. Thank goodness. We're almost done. I don't need to save that, but clear this up. On the last 3 physics exams, a student scored 90 and an 85. You might as well put these numbers down somewhere, and 86. Okay, what score must the student earn on the next exam to have a score an average above 90? Okay, so to take the average, you add up all the scores and then divide by the number of tests. He's going to take another test, so I don't know what that score is, but I do know that I have to add up all these scores, take that answer, the sum, and then divide that entire calculation by 4. And you want that 4, you want this number to be bigger than 90. He doesn't even want a 90. He wants something bigger, above 90. So what do we do? Well, first off, the first thing I would do is add up what we can do. Add up these numbers here. Because you can certainly add those up. We'll take a little calculator to do it. Okay, 90 plus 85 plus 86. And that thing is 261 plus X. That's a bundle. That bundle is divided by 4. And I keep using the word bundle, but basically what I'm saying is anything with pluses and minuses bundles those expressions together as one unit, one indivisible unit. Okay, so that's got to be bigger than 90. What I'm going to do is I'm going to multiply. See, this bundle is being divided by 4. I would like to get that division by 4 out. Cancel it so I can get the 4's canceling. And because I'm multiplying, and I got to do that from both sides, I am multiplying by a positive number. Don't change the direction of the arrow. Leave it alone. So cancel that. You're left with 261 plus x is bigger than 360. Make a better looking 3 right there, 360. Now, x is greater than 360. I'm going to subtract 261 from both sides. Has no bearing on the direction of the arrow. And so what I'm going to do is I'm going to subtract those two numbers. Okay, 360 minus 261 should give you a value of a 9. The guy's got to get a 99. 99. Okay. Okay. X is greater than 99. Guy's got to get 100. In other words, to do well. So that's good. That's good. Last. Car rents for $45 a day plus 21 cents a mile. You're on a daily budget of 66. What mileage will allow you to stay within your budget? Okay. Fresh sheet of paper. Don't save. Don't save. File new. Okay. Come up with a little expression that says $45 plus 0. Since you're dealing with dollars, convert those cents to dollars. So 0.1, $2.1. And what's called the mileage M. So every mile you pay 21 cents. Okay, then you add that to the base of 45. Okay, you want to make sure that that quantity has to stay within the daily budget, less than or equal to 66. Okay, you have $66 in your pocket. Okay, I can keep driving that car until the entire $66 is taken. All right, so there's no, in this case, you have to do the equals because it's okay for you to actually keep driving until you hit the $66 mark. So what do we got here? We need what mileage will allow you to stay there. Okay, so what I'm going to do is say, well, subtract 45 minus 45 on both sides, 0.21 m. Subtract 45, that doesn't mean anything with the direction. Remember, multiply or divide by a negative number. So 45 would be 21. Okay, so I subtract 45, get 21, then I divide by 0.25, which 21, which happens to be a positive number. All right, you're dividing by a positive number, so the direction of that arrow means nothing. M is less than or equal to 21 divided by that. It will be 100. 100. Okay, so there you go. 100 miles equals, well done. That's it. We're done. Yay, the video's over. All right, so chapter 2 is done. Now remember, after section 2. After you do this section, there's a quiz on section 2.5 and 2.6. Okay, so quiz 2B. Get that done. Then after that, there's an exam. Ooh, an exam. An exam that's based on chapters 1 and 2. Okay, a 20-question exam. Don't get too... If you're doing the homework well, if you're doing the quizzes well, there's no reason why you can't get the exam well. Okay, but so just make sure that an exam is different from anything else. Once you start the exam, you have to finish it. And you can't stop it and come back. So make sure you have at least an hour dedicated for you to take an exam. All right? So we'll see you in chapter 3. Thanks.